Hello and welcome to this Python course. The prerequisites for this course are none. This means that I do not assume that you have programmed before, so simply come as you are. To learn Python and programming in general, I strongly suggest that you experiment with the code that I demonstrate in the videos. To facilitate this, I have provided a GitHub link in the video description where you can access the Jupyter notebook containing all the code from the videos. In this course, I will teach you everything you need to get started with Python, and with so many people and companies using Python, the low threshold of learning it, and all the cool things you can do, such as data analysis, artificial intelligence, machine learning, web or software development, the question is not why you should learn Python. The question is, why shouldn't you? After finishing the course, you will have the background necessary to dive deeper into the specific applications that interest you. If you're thinking that it will be hard or even that you cannot learn Python, do not worry, since I will guide you through this course and you will be able to play and experiment with all the code examples which will enhance your learning experience. Finally, I have to say that I am very excited to teach you Python, so let's get started with learning this amazing and powerful programming language. In this course, I shall write my Python code in Jupyter notebooks, and there are different ways of accessing it, but I am personally using the Anaconda distribution. If you wish, you can do so as well, but if you don't, then do as you prefer or are used to. Just to be clear, you can follow this course either through Jupyter notebooks, which I will do, or an integrated development environment such as Spider or PyCharm, whatever you feel comfortable in. If you want to install Anaconda, you can do so at anaconda.com. Download the installer for your operating system, run it and then follow the instructions. If you get stuck, then Google your problem or look at YouTube where there is plenty of information, since this is a standard installation. In the next video, I shall give a quick tour of Anaconda. Once you have Anaconda installed, you can open up the Anaconda navigator, which I have placed here on my desktop. I have also already opened an instance of it, so I will go straight to it. In Anaconda, you can have different environments, which is useful if you, for instance, want to work with different Python versions or have different packages installed. To create a new environment, we simply press Create, select a name, the Python version you want to use, and Python 3 is the version currently in use, and Python 2 is a legacy version that is not maintained anymore. We can also install packages that are included in Anaconda. Later on in this course, we will use NumPy, so select All here, search for NumPy, select it, and then press Apply. And then once again you press Apply, but I will skip the details. Two other packages that we will use in this course are Matplotlib and Pandas, so you can install them as well. Why then can it be useful to have different environments? For example, if you read a book, you might want to be able to exactly follow the examples, and then it can be good to have a separate environment where you have exactly the Python version and packages used in the book, without having to mess up your Python environment that you usually work in. It can also be the case that you have some legacy code that has to be run on older Python versions, such as Python 2. Once we are in our selected environment, I have selected the base environment, we can for instance open up Spider, which is an integrated development environment where you can write your Python code. As a side note, we also have the programming language R available if we would like to use that. But in this course, I shall write the Python code in Jupyter notebooks, which makes it possible to code very interactively. So I will launch Jupyter. And once in Jupyter, we can create a new notebook by pressing New and then Python 3. In the next video, I shall give a tour of Jupyter notebooks. In this video, I shall give an overview of the Jupyter notebook. The first thing to notice is that we can change the name of the notebook. We can also save the notebook by pressing this button. And if we would like to get a tour of the notebook, we can press Help and then User Interface Tour. This tour takes less than a minute to finish, and I advise you to do it. In the notebook, we have two modes, Edit Mode and Command Mode. In Edit Mode, we can type in a cell. We enter into Edit Mode by clicking on the cell or pressing Enter. So I press Enter, and we see that we are in Edit Mode because there is a green border around the cell and a green left margin. We also see that we are in Edit Mode because there is a pen here at the top right. In Command Mode, we are able to edit the notebook as a whole, but not type into individual cells. We enter Command Mode by pressing Escape or anywhere outside the cell. So I press Escape, and we see that we are in Command Mode when there is a gray border around the cell and a blue left margin. We also see that we are in Command Mode because there is no pen here at the top right. To restore this cell as it was, I will press Ctrl Enter. And once in Command Mode, we can insert a new cell by pressing B, and we can delete the cell by pressing D twice in a row. So pressing B, we see that I have inserted a new cell, and pressing D twice, we see that I have deleted the cell. In Edit Mode, we can write text, headers or math symbols by changing the cell to Markdown, which is done either by pressing M on the keyboard in Command Mode or selecting the Markdown option in the Notebook toolbar. Here we have a cell that is in Markdown, and you can check yourself how I, for instance, created different headings and formatted the text in different ways. So I will restore this cell to how it was by pressing Ctrl Enter. We can also choose to write Python code by changing the cell to code. This is done either by pressing Y on the keyboard in Command Mode or selecting the code option in the Notebook toolbar. To run a cell, we press Ctrl Enter. To run a cell and continue to the next one, we press Shift Enter. And finally, to run a cell and insert one below, we press Alt Enter. And we see that we inserted a new cell below. When code is running, we see an asterisk. So we see that this code is now running because there is an asterisk. When the code in a cell is done, we see a number which keeps track of the order we ran our cells. So for example, this cell with number 2 was ran before this cell with number 3. If you want to interrupt a computation in progress, then press the button Interrupt the kernel. So I press this button and we see that the computation was interrupted. We can also restart everything by going to kernel and then pressing Restart and Clear Output or Restart and Run All. When restarting the kernel, everything will be removed from memory in our Python session. When learning a new programming language, it has sort of become a tradition that the first or among the first programs you create is to print out the message Hello World. So that is what we're going to do, and in Python this is straightforward. We start by typing print, parenthesis, the message we want to print out surrounded by double quotes. So I type double quotes, hello world. And to run this code, we press Ctrl Enter. And here we see that we have printed out the message, hello world, just as we wanted. So with this done, we have made an important step in the journey of learning Python, and we are ready to move on. See you in the next video. Now I'm going to give a short overview of some of the things we will learn in this course. At this stage, do not worry about details since these will be provided later. Okay, so we can do some basic calculations and comparisons. On line 6, for instance, I am exponentiating. More specifically, I'm taking 3 to the power of 2, which is 9. On line 12, for instance, I am checking if 3 is equal to 4, and that is false, which is exactly the answer that we got. Next, continuing to variables and containers. Variables in Python are created by assigning them a value. So for instance, here I am creating the variable x by assigning it the value 4. And once we have created our variables x and y in this case, we can, for instance, use them in a calculation and store the result in another variable z in this case. Containers are used to group objects together. So here I am creating a list which is called my first list, and later on in the course you will see that there are other types of containers such as tuples and dictionaries. Once we have created our list, we can extract elements from it. And one thing to notice is that indexing in Python is zero-based. This means that if we want to extract the first element, element A here, then we are writing a 0 here and not a 1. Also, the code here on line 7 will only extract the elements with indexes ranging from 0 to 3. The reason is that the right endpoint is not included. So the element G with index value 4 is not included, and this can be a source of confusion when you're learning Python. Iteration is a very important concept in programming, and here we are creating a for loop. Notice how we are using a colon here, and then the code that we want to repeat is indented. So in Python, indentation has a special meaning which is not the case in other programming languages. Here I am defining a function by using the keyword def, and my function is called isEven. And this function checks if the provided number is even. And recall that the number is even if the remainder after dividing by 2 is equal to 0. And we can do this calculation by using the modulo operator. Once this function is created, I can call on it by using its name and then providing an argument, 4 in this case. Arrays are very important if you're interested in, for instance, data science or machine learning, and to handle arrays in Python, we use the package NumPy. Finally, I have done some plotting, and to do them, I have used the package Matplotlib. And at first sight, it might seem like this is very complicated since there is a lot of code, but as you will see later on in the course, it is not. In Python, variables are created by assigning them a value. When naming variables, you can use a combination of capital and small letters, underscores and digits, but you may not start with a digit. So for example, if I try to run this code, this will return an error, and the reason is that I'm starting the variable name with a digit and that is not allowed. So I run this code by pressing Ctrl Enter and we see that we get an error. So basically the correct way to do this would be to name the variable like this, and if I press Ctrl Enter we see that we get no error, and the reason is because I am following all the name rules there are. In Python it is a convention that the variable names should be named in this form, lowercase with underscores. Here I have done an example on this, and this will be considered a good variable name because we are using lowercase letters separated by underscores. So I strongly suggest that you stick to this practice unless there are really good reasons not to. And in general, when you program, you want to have descriptive variable names because this will increase the readability of your code both for you and others. Before ending this video, the last thing I want to demonstrate is that when you have created a variable in Python, you can alter it. So basically, if I create a variable x by assigning it the value 3, and then I will print out my variable. So I press Ctrl Enter to check what x is, and we see that it is 3 because that's the value we assigned to it. Now after the variable x has been created, I can alter it. So basically I could type something like this: x is equal to x plus 3. And if I type print x again, then we expect to get the answer 6. And the reason is that we have said that the new value of x should be equal to the old value of x, which is 3 plus 3. And 3 plus 3 is 6. So I press Ctrl Enter to run this code, and we see that we got the value 6. If you would like to do the same thing in another way that is possible, we could type the following: x plus equal 3. If I print out x again, then we expect to get the number 9 because line 5 is exactly equivalent to this, but this is a little shorter notation. So let's print this out again, and we see that we got the answer 9. Just to demonstrate, there is a similar thing for multiplication. So if I type it like this, x is equal to star equal 3, and then print out x again. And here, just to make the code a little more beautiful, we should have a blank here. So I will do that. Okay, so if I run this code now, I expect to get the answer 27 because 9 multiplied by 3 is 27. And that's exactly what we got. In the upcoming videos, we're going to look at different types in Python. More specifically, we're going to look at numeric types, Booleans, and how they are used in if statements, and then finally strings. See you then. In Python, there are 3 distinct numeric types: integers, floats, and complex numbers. In this video, we're going to cover all 3 of them. Okay, so beginning with integers and floats. Here on line 2, I have created an integer. On line 3, I have created a float. And the reason why this is a float is because I'm using a dot here. So as soon as you use a dot, it will become a float. On line 4 and 5, I'm using Python's built-in functions, float and int. So as you can see, there are different ways you can create integers and floats. It's also good to be aware of that when you do an operation on an integer and a float, then the answer will be a float. So for example, here I'm doing 2 plus 3. 2 is an integer and 3 is a float. And then when I print out the result and the type of it, we see that the result is a float. Another example is here on line 7. I'm doing division. 5 divided by 3 where both 5 and 3 are integers, and then I print out the type. And again we see that it is a float. And this is very natural, because if it were not the case, this would lead to quite strange results. It is also good to at least have heard it once, that floats in Python, and not only in Python but other programming languages as well, are not exact. So for example, from mathematics, we know that 0.4 minus 0.3 is exactly equal to 0.1. But when I print out the result, we see that the answer is not 0.1. And then on line 4, I am comparing 0.4 minus 0.3 with 0.1, and we see that they are not equal because we get the answer false. And long story short, the reason for this is that floats are represented in the computer as base 2 fractions. This means that they are not exact. If you want to read more about that, you can check out this link. And it is good to be aware of, but it's nothing to worry about, at least in this course. Finally, we can handle complex numbers as well. In Python, the imaginary part is represented by an j, as you can see here. And then when I print out the type of z, we see that it is complex. And then finally, I'm doing some basic calculations. But if you're not familiar with complex numbers, do not worry, since we will not use it anymore in this course. When you compare two values, the expression is evaluated and Python returns the answer true or false. True or false is of the type Boolean. Booleans were named after George Boole, who among other things worked with logic. Okay, so let's check some examples. Here on line 1, I'm checking if 10 is greater than 20, and that is false. On line 2, I'm checking if 10 is greater than or equal to 10, and that is true. On line 5, we are checking if 10 is equal to 5, and that is false. Also notice that here, when we check if 10 is equal to 5, we are using two equal signs. And on line 6, we are checking if 10 is not equal to 5, and that is true. Finally, we can check the type. So for example, 10 greater than 2 will evaluate to true, and then we're checking the type of true, and we get that it is a Boolean. And then I'm demonstrating that once again, basically here on line 11, where I print out the type of true, and just as expected, we get a Boolean. Booleans are often combined with if statements to achieve powerful conditional logic. So let me give an example. Assume that we are selling a product whose price is equal to 5. So I will type price is equal to 5. And then, depending on what the price is, we want to print out different messages. So now I will write some code and then explain it in a moment. So with this code, I am printing out different things depending on what the price is. For example, if the price is equal to 10, then the code after the colon that is indented will be ran. So in Python, indentation has a special meaning which is not the case in other programming languages. So if the price is 10, we will print out the price is 10. If that condition is not true, then we go to the next statement, and elif stands for else if. So else if the price is equal to 15, then print out the price is 15. If neither of these two statements are true, then we are executing the else statement and are going to print out the price is neither 10 or 15. So in this example, since the price is 5, we expect this message to be printed out. So I will press Ctrl Enter to run the code, and we see that we got the message that we expected. If I change the price to 10 and run the code again, then we expect to get this message. I press Ctrl Enter to run the code, and we see that the message that was printed out is that the price is 10. So this was a made up example, but I hope that you see the power of using conditional logic. So try to come up with some own examples and play with the code. In Python, you can enclose strings in either single or double quotes. It doesn't really matter which way you choose, as long as you stick to one method to be consistent. Okay, so here I have created a variable called myText, and I am assigning it the string Python is awesome. And I have to say I totally agree with that. Next, I print out the variable, and then I check the type of it. And we see that we print out the message just as expected. And we also see that the type of the variable myText is string. If you, for instance, would like to type his, like I have done here, then this will return an error for obvious reasons. And to bypass that, you can use double quotes instead. So if you use double quotes like I have done here, then no error will occur. We can also print out a new line in Python. So the way to do that is to use slash and n. So slash and n returns a new line, as you can see in this example here. Then we can also use multi-line strings. And the way to do that is to use triple double quotes. You could, if you want to, use triple single quotes, but if you read the official Python style guide, then they recommend to use triple double quotes instead of triple single quotes. So I definitely recommend you to use triple double quotes. And then finally, I have done some operations on strings. More specifically, I have added and multiplied strings, and you can check what the result becomes. Formatted strings, or f-strings, make your code more dynamic and allows you to add variables to a string. So in this example, I have created two variables, month and year, and then f-strings are always started with an f before the quote. And then the variables that you want to add in your string are enclosed in brackets, just as you can see in this example with month and year. So if I press Ctrl Enter to run this code, then we see that we get the message "It all started in February 1991" printed out. And what's really cool is that if I, for instance, change the year to 1996 and press Ctrl Enter to run the code again, then automatically the string has changed. So f-strings is a powerful concept that makes your code more dynamic, and it's something that you definitely should have in your Python toolbox. Containers are used to group objects together. The core built-in containers in Python are lists, tuples, dictionaries, and sets. These different containers have different properties and are useful in different situations. In the upcoming videos, we are going to cover all of these containers. In Python, lists can contain items of different types. They are mutable, meaning that we can change the content, and we can also index them to get a single element or slice them to get a sequence of elements. To create a list is straightforward. We use square brackets and then we separate the items by a comma. And notice that the values in this list are of different types. The 5 is an integer, the 9 is a float, and Python is a string. In this cell, I am also going to print out the variable L and print the type of the variable L. So I press Shift Enter to run this code, and we see that we have printed out our list, and just as expected, the type of our variable L is a list. If I execute this code, we're going to extract the first element in our list, and the reason for why it stands as 0 here and not a 1 is because in Python, indexing starts from 0. So if I press Shift Enter to run the code in this cell, I expect to get the answer 5, which is exactly what we got. If I execute this code, I'm only going to get the elements with index values ranging from 1 to 3, and the reason is that in Python, when you slice, the left bound is included while the right is not. So if I run this code, I expect to get the answer 9, 12, and Python. So I'm pressing Shift Enter, and we see that 9, 12, and Python is exactly what we got. Finally, we can change the content of our list, and if I run the code in this cell, we're going to change the second element in our list to 99, and I press Shift Enter, and we see that indeed the second element has been changed to 99. When indexing and slicing lists, the two main things to have in mind is that indexing starts from 0, not 1, and when slicing a list, the left bound is included while the right is not. So in this example, I have created a list that I call L1, and then I'm doing some basic indexing. So on line 4, we will get the first element because we use the index value 0. And then if we want to, we can also index our list from the right instead from the left. And that can be achieved by using negative index values. So if I use the index value -1, I will get the last element. When slicing, you provide a start value, a stop value, and if you want to, you can provide a step value. But if you omit it, it is going to be 1 by default. So on line 6 to 8, I'm giving some examples on slicing, and you can check those out. Here I give some more examples on slicing that perhaps are less common. So on line 3, I'm going to get all the elements. On line 4, we're going to get every second element. And then on line 5, we are basically reversing the list by using a step of -1. The two final things that I want to demonstrate is that if you slice out of bound, then you will get an empty list. And if you index out of bound, then you will get an error. Methods are functions available for a given object, which will be lists in this video. So in this example, I have created two lists, L2 and L3. And then on line 4, I'm using the append method, whereas on line 8, I'm using the extend method. The difference between these two methods is that append will add the whole list as one element, whereas extend will add each element individually. Now a small detour on indexing and slicing. If we index the -4th element, then we're going to get the whole list. And if we would like to get one element in this list, then we can simply use one more square bracket as I have done here. Okay, back to methods. The pop function removes and returns the element with a specific index value or the last element if no index value is provided. So on line 6, I'm removing the element with index value 6, and on line 10, I'm removing the last element and storing it in the variable last. We can also reverse a list by using the reverse method. And then finally, we can count the number of times an element occurs. So in this case, I'm counting the number of times the element 1 occurs. And we can see that it is 2 times, and we get the answer 2 just as expected. List comprehension is an elegant way to create a new list based on the values of an existing list. So in this example, I've created a list called numbers, and then I'm creating a new list by taking x multiplied by 2 for x in the list numbers, and I'm using as a condition that x should be greater than or equal to 1 or smaller than or equal to 3. So I press Ctrl Enter to run this code, and we see that the values 1 to 3 have been multiplied by 2 to create our new list. So for example, 1 multiplied by 2 is 2, and 2 multiplied by 2 is 4. Notice that when we use list comprehension, we do not need to use a condition. So I can remove this condition here, and then press Ctrl Enter to rerun the code, and then we see that all the values in the original list have been multiplied by 2 when we create our new list. Finally, note that we do not need to use x as our variable name. For example, we could call x for apple pie instead. So I will change this x to apple pie as well. And then press Ctrl Enter to rerun the code, and then we see that it works just as before. Tuples are immutable, meaning that you cannot change them. This property is, for instance, useful in situations when you know that the data should not be changed, and this will then make your code more robust and safer. Okay, so to create our first tuple, we simply use parentheses and then separate the values with a comma. And just to be clear, you can also create a tuple by not using parentheses and only separate the values with a comma, as I have done here. But in general, it's more clear to use parentheses, so that's the general recommended approach. So if I run this code, I press Shift Enter, then we see that we have created two different tuples. As I said in the beginning, tuples are immutable, so if we try to change the first element to a 5, then this will give an error. So I press Shift Enter to run the code, and we see that we got an error. So tuples are immutable. Indexing and slicing can be done just as we did for lists, so this is nothing new. I simply press Shift Enter to run the code, and we see that we have indexed and sliced our tuple. In the final example, I demonstrate that if you wish to create a tuple with one element, then you will have to use a comma at the end, just as I did here. The reason is that this line here, line 2, will only create an integer. So I press Ctrl Enter to run the code, and we see that the first instance is an integer, while the second instance is a tuple. So to create a tuple with one element, you'll have to use a comma at the end. Dictionaries are created by a key value pair and are indexed by using their keys, which are also immutable. So in this example, I'm creating a dictionary called register, and notice how I use curly brackets, specify the key, colon, and then the value. On line 4, I'm going to print out the value whose key is 3. And looking at our dictionary, we see that that is Bjarne. And then on line 5, I'm going to print out the type of my variable register, so I expect to get the answer dictionary. So I press Shift Enter to run this code, and just as expected, we got Bjarne and then dictionary as the type. Finally, adding a new person in our dictionary is easy. We simply specify the key and then assign it a value. So I press Ctrl Enter to run this code, and then we see that our new register contains Dennis. Sets are unordered collections with no duplicate elements. To create a set, we can either use curly brackets or the set function. So I will create these sets by pressing Shift Enter, And next we can ask ourselves, is set1 equal to set2? And the answer that we expect to get is true. And the reason is that set1 only contains duplicates of the elements in set2 that are of different order. So I will run this code by pressing Shift Enter, and just as expected, we got the answer true. We can also perform basic mathematical set calculations, such as union, intersection, and difference. So first I create two sets, A and B, and then when I calculate A union B, we will get all the elements that are in at least one of the sets. So I expect to get the answer 1, 2, 3, and 4. When we calculate A intersection B, we will get all the elements that are in both of the sets. So we expect to get the answer 2 and 3. When calculating A difference B, we will get all the elements that are in A but not in B. So we expect to get the answer 1 and 4. So I will run this code by pressing Shift Enter, and we see that we got the answers that we expected. Finally, to create an empty set, we cannot use curly brackets with nothing between them. The reason is that this will create an empty dictionary. So to create an empty set, we have to use the set function. I will execute this code by pressing Ctrl Enter. It is straightforward to convert lists, tuples, and sets from one container type to another. So here I first create a list, a tuple, and a set. And in the code block below, we see that I convert one container type to the others. So for example, here I have created a list from a tuple. Here I have created a list from a set. And then on line 6 and 7, I'm converting a list and a set to a tuple. And then finally, I convert a list and a tuple to a set. So container conversion is straightforward. In the next video, I will provide examples on why this can be very useful. See you there. Different containers have different properties. This can be exploited to solve different kind of problems. So in the first example, we have two lists, L1 and L2, and we want to see if they contain the same elements where we do not care about either order or duplicates. This can easily be solved by checking that the set of L1 is equal to the set of L2. So I run this code by pressing Shift Enter, and we see that indeed they contain the same elements where neither order or duplicates matter. Next, we have two tuples, T1 and T2, and the question is, what elements does T1 and T2 have in common? This problem can be solved by using the intersection method of sets. So we intersect the set of T1 with the set of T2, and I run this code by pressing Ctrl Enter, and we see that the elements that are in both tuples are 105, 10, and 100. If you wish, you can check this manually, of course. So with these two examples, we have seen that container conversion can be very useful. Lists, tuples, dictionaries, and sets are iterable objects, meaning that we can traverse through their values in a for loop, for example. So in this case, I've created a list called players, and I'm going to write a for loop to traverse through the list and print out each player. So I start by typing for I in players, print I. Notice that the code we want to iterate comes after the colon and is indented. So in Python, indentation has a special meaning which is not the case in other programming languages. So to run this code, I press Shift Enter, and we see that our for loop has executed and printed out each player in the list. It is quite common to call the looping variable I, but you can pick any other name. So in this case, we might pick player instead of I because it's quite descriptive. So I will copy this code, paste it in, and then change I to player. I will now execute this code by pressing Ctrl Enter, and we see that the result is exactly as before. The range function is often used for looping a specific number of times in a for loop. In general, you provide a start, stop, and step argument, but if you only provide one argument, then that is equivalent to starting from 0, where the step is equal to 1. If you provide two arguments, then that is equivalent to using a step equal to 1. Okay, so in this example, I've created an empty list called L that we are going to fill with values. In this for loop, I'm using the range function, starting at 0, stopping at 10, and using a step of 2. For each iteration, I will print out the looping variable I, and then I will append the looping variable I multiplied by 10 to my list L. So I press Ctrl Enter to run this code, and we see that I have printed out the values that we have iterated through. Notice that the 10 is not included, and the reason for this is that the right bound is not included, which was also the case for slicing, if you recall that. Finally, I print out my list L, and we see that I have appended each value from the loop, but multiplied by 10. So for example, 0 multiplied by 10 is 0, 2 multiplied by 10 is 20, and so on. So this was a demonstration on the range function. Try it out. We can easily keep track of the iteration number by using the enumerate function in a loop. So here I first create a list called players, and then by using the enumerate function we get a counter that I call iteration number. You can call it something else if you want to. And then I am printing out the iteration number and I. So I press Ctrl Enter to run this code, and we see that we have counted our iterations. One approach that you sometimes will come across is this code here. So it achieves the same thing as above by using the range and len function, but in general the approach with enumerate is recommended. Nevertheless, I am showing this code here if you should come across it sometimes. So I press Ctrl Enter to run this code, and we see that we achieved exactly the same thing as above. But once again, I want to say that this approach here with enumerate is the recommended one. It is possible to create nested loops, meaning you use a loop inside another loop. In this code here, I have created a double for loop, and it would be an excellent exercise to try figuring out what this code does. If you want to think about it, then pause the video. Okay, so what this code does is that it creates a multiplication table where each number is multiplied by all the numbers from 0 up to the specific number specified here on line 2. On line 5, I'm also using f-strings, which is something that we went through earlier on in this course. Okay, so I press Ctrl Enter so you can check the result of this code. And notice that the 5 is not part of the multiplication table. And the reason for this is that in the range function, the stop value is not included. The while loop executes as long as the condition evaluated remains true. So I press Ctrl Enter to run this code, and this code will run forever because the condition 1 is less than 5 is always true. To stop the code from running, we can press this button here. And one way to create a while loop that doesn't run forever is to increment the variable that is used in the condition. So we start by creating the variable I and then assigning it the value 0. And then in the while loop, we increment I with 1 for each iteration. Notice that the notation I plus equal 1 is equivalent to I is equal to I plus 1. So I press Ctrl Enter to run this code. And then we see that when the condition I is smaller than or equal to 10 is false, then the loop is stopped. So the while loop is important to know about, but nevertheless, the for loop is much more frequently used. We can iterate through the items, keys, or values in a dictionary. So I begin by iterating through the items in the dictionary called customer age. And this is achieved by using the items method. And notice that the objects we print out are tuples. If we would like to print out the keys and values separately, that is also achievable by using the items method. But now we unpack the tuple by using two variables in the loop. So we see that now we get a string for the key and an integer for the value. Finally, if we want to, we can iterate through the keys by using the keys method, and we can iterate through the values by using the values method. So try this out. Assume we have the following scenario. We want to check if two numbers are even, and for this we can use the modulo operator to check the remainder when dividing by 2. If the remainder is equal to 0, then the number is even, else the number is not even. So here we check if 4 is even, while here we check if 3 is even. As you can see, this code is very similar. The only thing that differs is that here we have a 4 and here we have a 3. So if we, for instance, wanted to check 10 numbers, say, then we would have to include a lot of code that's very similar. So to solve this problem, we can use functions allowing us to basically reuse code. So to create a function, we use the keyword def, which stands for define, specify the name, is even in this case, and then the parameters between parentheses, and then finally a semicolon. The code that is executed when calling the function is indented, so in Python, indentation has a very, very special meaning. After defining the function, we can easily call it by using its name and then specifying an argument. So with this code here, I'm checking if 4 is even and 3. As you can see from the answer, 4 is even while 3 is not. So I end this video by emphasizing that functions are a very important concept, not only in Python, but programming in general. By convention, functions should be named in lowercase with words separated by underscores. So the function name is underscore even is a name that follows that convention. If you have a documentation string, which you should if you want to write good code, then the first line should be a concise summary of the purpose surrounded by triple double quotes. So that is basically the minimum information that you should provide. Here I show a more complete example on how a docstring could look like. So we provide a summary of the purpose. information about the parameters, information about the return value, and then some examples on how to use the function. So as you can see, writing a documentation string of this type really makes the function a lot easier to use and understand. Finally, I would like to end this video by saying that the example we just looked at was taken from the following link. It is possible to access the documentation string by this code. So the function name range in this example, followed by a dot, double underscores, doc, and then double underscores. So I run this code by pressing Ctrl Enter, and here we see the docstring of the range function. We can also access the docstring by using the help function, but the help function provides the docstring and also more information when available. In Python, by default, arguments may be passed to a function either by position or by keyword. So in this example, I've created a function that's called sum2numbers, and that's doing exactly that, summing two numbers. And then on line 4, I'm providing two positional arguments. On line 5, I'm providing two keyword arguments. And then on line 6, I'm providing one positional and one keyword argument. So if I run this code by pressing Shift Enter, we see that all three approaches works equally fine. Finally, if you provide one positional and one keyword argument, then the positional argument must always come before the keyword argument. So if I run this code by pressing Ctrl Enter, we see that we get an error because the positional argument follows the keyword argument. In Python, it's possible to have default arguments, and they must come after non-default arguments. And just as before, you can pass the arguments by either position or keyword, it doesn't matter. So in this example, I've created a function that's called multiplier function. And what it does is that it multiplies a provided argument x with a multiplier that is equal to 10 by default. So on line 5, we're going to multiply 5 with 10 because that is the default value. And notice that we have only provided one argument. We do not need to provide two arguments because we have a default value. So we expect to get the answer 50 here on this line. And then on line 8, I'm multiplying 4 with 5, and notice that now I'm using 5 as the multiplier instead of the default value of 10. So we expect to get the answer 20. I run the code by pressing Ctrl Enter, and just as expected, we got the answers 50 and 20. It is possible to restrict the way arguments can be passed to a function. So the general syntax is that arguments before a forward slash may only be positional. Arguments after an asterisk may only be keywords. And then arguments in between can be either positional or keywords. So here I've created a function called keyword arguments only. And as we can see, it works fine when providing keyword arguments, but it returns an error when providing positional arguments. Here I've created a function called positional only, and as we can see, it works fine when providing positional arguments, but returns an error when providing keyword arguments. Here I've created a function that requires 3 arguments, and one way to call this function would be to simply provide 3 arguments, as I've done here on line 5. Another way to call the function would be by unpacking a tuple which return positional arguments. A tuple is unpacked by using a star, as I have done here. Finally, we can call the function by unpacking a dictionary which return keyword arguments. A dictionary is unpacked by using 2 stars, as I have done here. It is possible to define functions that accept a varying number of arguments. If we use 1 star, then we can use a variable number of positional arguments, and if we use 2 stars, then we can use a variable number of keyword arguments. So here I've created a function that's called SumNumbers, and it's accepting a variable number of positional arguments. So I run this code to define the function. And then here I'm calling the function with 3 arguments, and here I'm calling the function with 10 arguments. So I run this code by pressing Ctrl Enter, and we see that both ways to call the function works. Finally, you can do a similar thing with keyword arguments. If you're interested, check it out. It is possible to create functions that return multiple values. So here I've created a function called f, and it returns the argument provided, the argument squared, and then the argument cubed. In this code, I'm storing the function's return value in a variable called firstMethod. When I print it out, we see that we get a tuple containing 3 values. If we, for instance, would like to extract the element with index value of 1, then that is easily done, as I've done here on line 4. Finally, we can, if we wish, return the answer in multiple variables by using tuple unpacking. So here we are storing the return values in 3 separate variables. One of the benefits of using classes or object-oriented programming is that it makes your code well organized, easier to maintain, and user-friendly. To have a good understanding of Python, you must have basic understanding of classes. At the beginning, I have written down a quote from the Python tutorial that I believe is an excellent description of classes. I strongly recommend you to pause the video and read the quote. Okay, now I will provide some important terminology that we will use when learning about classes. At this stage, it is good to have heard about the terminology, but do not worry if it seems a bit abstract, since we will dive into examples soon. So a class is basically a blueprint or template for how to create objects that share characteristics. An object is an instance of a class. So for example, I is equal to 10 is an object that is an instance of the integer class. Attributes hold data that are either part of a class and are then called class attributes, or an instance and are then called an instance attribute. Methods are simply functions that are part of a class. And with inheritance, one class can inherit capabilities, such as methods, from another class. Finally, I end this video by saying that class names should normally use the capwords convention. In Python, everything is an object, and each object has a class from which it is instantiated. So here I've created an integer I, and then I'm checking if I is an instance of the integer class. So we expect to get the answer true, and running the code we see that we get the answer true, just as expected. Now I'm going to create a very simple class called test class, and this class does absolutely nothing because I use the keyword pass when creating my class. Once we have created our class, we can create an instance, x, by calling our class as if it were a function. But notice that a class is not a function. This was a rather boring example, so classes often want to create objects that have an initial state. To achieve this, we can use the init method, which is automatically invoked when creating a class instance. The first argument, self, is referring to the instance itself. The instance shall have an attribute called name that we assign the argument name of student to. The instance shall also have an attribute called age that we assign the argument age of student to. Okay, so we have our class definition. Next, we create an instance called student1, and this time I also provide two arguments. These two arguments shall be the values of the name and age attributes respectively. Once the instance is created, we can always access our attributes by using the dot notation as I have done here. But wait, we only provided two arguments, whereas three arguments should be provided as specified here in the init method. And the reason for this is that the instance itself is passed as the first argument. When creating classes, we can also use class variables or class attributes, which all instances of the class have. So here I have added a class variable called teacher with the value Antonio assigned to it. So when creating an instance, just as before, we assign the instance attributes, name and age in this case, but now these instances, student1 and student2, automatically have the class attribute teacher. Finally, I also added a docstring to our class, and we can access it by using the doc attribute. I have now added a method, addGrade, to our class, and methods enable us to change the state of an instance. So when you define a method, the first argument should once again be self, because we are modifying the state of an instance itself. So here I have created an instance, student3, and to that instance we are adding a grade by using our addGrade method. Finally, we can access that student's grade attribute. In this example, I have created a class called the parent, and this class has a method called isItAPet. Next, I'm creating a new class called dogs, and this class will inherit the method isItAPet from the parent class the parent. As we can see here, inheritance is achieved by passing the parent class as an argument. So here I'm creating an instance called doggy, and when initializing it, provide the name Bob and say that the dog is 3 years old. As we can see here, I have used the method isItAPet, which is possible since we have inherited that method from the parent class. So this example demonstrated that we could use a method defined in another class if we use inheritance. A program will stop executing when an error occurs, meaning that the rest of the code will not run. So if I run this code, these two lines will be printed out. Here an error will occur because division by 0 is not defined, and because an error occurs there, the code below will not be executed. Okay, so I run this code and we get the expected outcome. We only got these two printouts. If your code, for instance, takes several hours to run, there is a high probability that you do not want your code to stop running when an error occurs. Instead, we can catch the exception, which we will learn more about in the upcoming videos. We can protect our code from stop running when an error occurs by catching exceptions. So here we will try to divide 10 by 0, which will yield an exception since division by 0 is not defined. And because an exception occurs in the try clause, the except clause will be executed. So I run this code and we see that the except clause was executed. If I change this to 10 divided by 2, the except clause is not executed since no exception occurs in the try clause. In general, this is bad coding since our except clause will catch all exceptions, meaning that we can catch things we did not have in mind. So we should be more specific, and in this code, the except clause will only be executed if there occurs a 0 division error in the try clause. So I run this code and we see that this except clause was executed because we divided by 0. Finally, as we can see here, we can have multiple except statements to cover multiple cases. So here I'm referring to a variable that has no value assigned to it, meaning that the except clause connected to the name error will be executed. In the previous video, we used two built-in exceptions, name error and 0 division error. If you would like to read more about the built-in exceptions in Python, I have here provided a link. And for instance, here we can read more about the name error exception that we used in the previous video. So check this out. The try except statement has an optional else clause that is executed if the try clause raises no exception. So in this code, I'm going to divide 10 by 2, which will not raise any exception, and hence the else clause will be executed. So I run this code, and just as expected, the else clause was executed. In this code, I'm dividing 10 by 0, which is not defined, and will hence raise a 0 division error, and because of that, the except clause rather than the else clause will be executed. So I run this code and we see that the except clause was executed. Finally, using the else clause is better than adding additional code to the try clause because it avoids accidentally catching an exception that wasn't raised by the code being protected by the try except statement. The try statement has an optional finally clause which is intended to define cleanup actions that must be executed under all circumstances. So here I define a function that will divide two arguments a and b. I have an except clause for the 0 division error. I have an else clause that will be executed if no exception occurs. And then I have a finally clause that will be executed under all circumstances. So here I'm dividing 10 by 2, which raises no exception, meaning that the else clause is executed, and also the finally clause, since it is always executed. Here I divide by 0, which triggers the except clause, and once again the finally clause is executed. Finally, I divide two strings, which yields the exception type error that we did not catch, but nevertheless the finally clause is executed. It is possible to raise exceptions, and in this example I've created a variable x that is a string, and then I say if x is not an integer, then raise a type error. So if I run this code, we see that we got a type error, and the reason for this is that x is not an integer. If I would change the variable x to an integer, let's say 10, and rerun the code, then we won't get any exception. NumPy is a library for Python that allows us to handle arrays and is a must-have in your toolbox if you, for instance, are interested in machine learning, data analysis, or scientific computing in general. Okay, so we begin by importing NumPy as NP, and this means that we will be able to access the library with the short notation NP instead of having to write NumPy every time. Here I create an array A and then check the shape and type of it. For example, we see that A has 3 rows and 2 columns. Notice that I write NP when creating the array A instead of NumPy, and the reason for this is that we imported NumPy as NP. Once we have our array, we can, for instance, sum the elements. So line 3 will sum all the elements in the array, whereas line 6 will sum the elements across each column. This is achieved by specifying the axis to be equal to 0. In the same way, if we specify the axis to be equal to 1, we will sum the elements across each row. Finally, we can index and slice our array, which I have provided some examples on here. In this video, I have created 2 arrays, A and B, and I'm going to demonstrate that we can do some different operations on them. So here, for example, I'm doing element-wise subtraction by simply typing A minus B. Here I'm doing element-wise multiplication by typing A multiplied by B. And then finally, if you know some basic linear algebra, we can also do matrix multiplication. So we have done the first steps in learning NumPy, but it is far from covering even the basics. If you would like to learn more about NumPy, I can recommend NumPy's own user guide available at this link. For example, you could check out the user guide NumPy The Absolute Basics for Beginners. Now we're going to cover plotting in Python, which we will do with the Matplotlib library. Before we continue to the concrete examples, I will cover some important remarks and terminology. So, plotting with Matplotlib can be done in either of 2 ways: the object-oriented approach or the pyplot or MATLAB style. In general, it is recommended to use the object-oriented approach, especially for more complicated plots and plots that are part of a bigger project. However, the pyplot or MATLAB approach can be used for quick interactive work, and both of these styles are used in the documentation, and this can be a source of confusion for beginners. Also note that when you create a figure in the object-oriented style, you still use the pyplot submodule. Some important terminology in Matplotlib are figure. This is the whole figure and can be seen as a canvas. Axis is the part of the canvas that the plot is attached on. We call methods that do the plotting directly from the axis, which gives high flexibility in customizing our plots. Axis sets the scale and limits and generate ticks and tick labels. And notice that axis and axis are 2 different things. Basically, everything visible on the figure is an artist. When plotting with Matplotlib, you should in general use NumPy arrays as input, or objects that can be transformed to a NumPy array with the function asArray. Finally, I will show a descriptive figure, which is good to have in mind when we continue to learn plotting with Matplotlib. We are now going to create a plot with Matplotlib, and first we import the packages that we need: the pyplot submodule, which we alias as plt, and NumPy. Then I create a figure and axis object, which gives a quite boring result since we haven't plotted any data. So to make things more interesting, we first generate 100 evenly spaced data points from -4 to 4, and then say that y is equal to x squared. When doing the plot now, we simply call the plot method directly from the axis object, and this is the object-oriented approach. We could do the same plot with the pyplot or Matlab approach, which can be faster for quick interactive work, but in general we should use the object-oriented approach. Finally, I would like to emphasize that in this example we made a plot in the object-oriented approach and in the pyplot or Matlab approach. But in both cases we used the pyplot submodule, which we have aliased as PLT. That we use the pyplot submodule in both cases can be a source of confusion. In this video, I shall shortly demonstrate that we can do a more advanced plot quite easily. So I have changed the line style, added a label that will be displayed in the legend, and also added an X label, a Y label, and a title. In our plot, we see that we have changed the line style, added a legend, and added an X label, a Y label, and a title. We could, if we want to, create the same plot in the pyplot approach, which makes plotting work like in the programming language Matlab, if you have heard about that. But once again, in general, the object-oriented approach is the recommended one, unless you're doing quick interactive plotting. Finally, I could make our plot slightly more advanced by changing the size and also adding arrows, but I will leave it for you to check the details of that if interested. So in this plot, I have made 4 subplots where I have a line plot, a scatter plot, a bar plot, and then a histogram. This is straightforward to do. In the subplots function, I specify that I want 2 rows, 2 columns, and then the axis object is going to be a NumPy array. To decide where to put a subplot, I use array indexing, as I have done here. So axis 0, 0 is going to be the top left plot, and axis 0, 1 is going to be the top right plot. So I encourage you to look through this code and try it out yourself. So we have learned the basics of Matplotlib. If you're interested to learn more, you can go to the website of Matplotlib and then go to tutorials and begin by reading the introductory tutorials, and then if you're interested, you can continue with the intermediate and advanced ones. When working with tabular data, such as data stored in spreadsheets or databases, Pandas is a powerful library to use. In Pandas, a data table is called a data frame. So we begin by importing Pandas as PD, and next we will import some data from an Excel file. So let's look at how this Excel file looks like. So in this dataset, we have some students and their grades for math, English, and programming. Notice that some students have a missing grade due to not having done the exam. So for example, Joe does not have an English grade. Notice that when I read in the Excel file, I do not specify a full path, and the reason for this is that my Excel file is placed on the same place as my Jupyter notebook. Finally, I'm displaying the data that we just read in. Once we have loaded our data, we can next inspect it. If we want to get a concise summary of our data frame, we can use the info function, and then we see how many non-null values each column have, and also the data type of the columns. If we want to see the first rows, we can use the head function, and by default it shows the first 5 rows. If we, for instance, want to see the first 2 rows, then we simply type n is equal to 2, and we see that we get the first 2 rows. Finally, if we want some descriptive statistics, we can use the describe function, and for instance, we see that the mean math grade is around 3.18. Note that the missing values are not included in the descriptive statistics. Here I have sorted my student data by name, and we see, for instance, that Ashley comes before David, and the reason for this is that A comes before D in the alphabet. If I go down and print out my data frame students again, we see that the data is not sorted by name, and the reason for this is that we did not do the operation in place. If we would like to do that, then that's simple. We simply type Inplace is equal to true, and when we then print out our data frame students again, we see that the data itself has been sorted by name. So by specifying the Inplace is equal to true option, we sort the data itself. Once we have a data frame, we can select data from it. For example, we could select a single column, or we could select a couple of rows. In Pandas, we can also access a group of rows and columns by labels by using lock. Notice that when using lock, contrary to usual Python slices, both the start and stop are included. We can also select data by position or integer-based indexing by using ilock. Finally, iat is used to access a single value by integer position. The same thing could be achieved by ilock as well, but it is not as fast. If we want to access a single value by label, we could use at. This could also be achieved by lock, but once again, it is not as fast. In reality, missing data is a common situation and we can handle it with Pandas. So in our students' data frame, we see that there exists missing values. And one way to handle this is to simply drop the rows that contain a missing value. And this can be achieved by using drop NA. If you would like to do this operation in place, then use the Inplace is equal to true option as an argument. Another alternative is to fill the missing values with the mean of each column. So the mean of the math grades is around 3.18, and then everybody who has a missing math grade will get the value 3.18 filled in. To make a plot from a Pandas data frame is straightforward, and in this example I create a histogram for each numeric column in our student's data frame. If you would like to learn more about Pandas, then you can go to their website, then to User Guide, and begin by reading 10 minutes to Pandas. And then if you want to, you can continue by reading Intro to Data Structures and then Essential Basic Functionality. If you have made it this far, congratulations on finishing the course. Now when you have finished the course, you may be thinking of what the next steps are. One alternative is to go to python.org and then to Docs, Tutorial, and here you can read the official Python tutorial. If we go back to the home page, we can also go to Documentation, Python books, and for instance check out introductory or advanced books, specific applications, or at the bottom of the page, a list of free Python books. If you would like to do some Python challenges and exercises, then there are multiple websites for this, and one of them is this one. Here you could for instance begin by Python Basic Part 1, and this is a good way to learn and practice your Python skills. All feedback about this course in the comment section is much appreciated, and make sure to like the video and subscribe to the channel if you would like to see more content in the future. Finally, it has been a pleasure creating this course, and I hope you have learned something new. Thank you for watching and hope to see you in the future. Bye.